Good afternoon and welcome to Exploration Place. I am Daniel and I am here in our Digital Dome Theater and Planetarium for our very first Twitch broadcast. I feel a little twitchy at 2 o'clock on Tuesday, and we are going to be talking about all kinds of different things in the coming weeks. But today we are going to focus on the International Space Station. I don't know if you know anything about the International Space Station, so I'm going to keep it pretty basic, at least starting out, and then we will build from there. But right now, we are looking at our dome theater as it looks to the presenter in the back. We have what's called a viewport, and the viewport gives us this view here. And we are using dark matter from Skyscan. And that software has some really great graphics. And what we're looking at here, you can see the Earth. It is round, and we have got an orbit. The orbit going around is the International Space Station, so we can see its path. Now, if we want to go to the International Space Station, which happens to be orbiting around 200 and some odd miles above Earth, so you can see that that's not very high over our atmosphere. If I was to zoom us in here just a bit, and I'll orbit us around a little bit, we'll see where that orbit path is at right now. As the space station goes around, it takes it about 90 minutes to go around the Earth once it is traveling a little over 17,500 miles per hour, or about 5 miles per minute, or 5 miles per second, 5 miles per second. And at that speed, it sees 16 sunrises and sunsets a day. So if you are on board the International Space Station and you have some kind of sleep issue with sunrise and sunset, you are going to be very, very sleepy the entire time you're on board the space station. But let's go ahead and fly to the space station. We'll fly. We have two options in this screen. We have the flying and we have the teleporting. The flying view is going to take us right here through the planet Earth because the space station was on the other side. And now we're going to come out the other side of the Earth. And here we are at the space station, and it looks like it is on the dark side of our Earth. So I'm going to, do some fun flying around here. Let's do this again. All right, there we are. There we are at the space station. And you can see that we have got the space station moving just a little bit. Let's stop that motion. And we're also going to turn off the orbit so we get that line out of our way, because that line can get a little irritating. But the space station itself is right there. All right. Computer is having fun today driving our space station. So we are, I figured it out, I believe. All right, so there we can see the space. This is actually the Milky Way here in the background, and we are going to, there was a setting set on our International Space Station that was making us fly around it instead of to it, and that is always a bad thing. All right, so here comes the space station, and we can see the space station from a distance. We're going to stop moving. There we go. And all right, let's go take a look at the inside of the, actually we'll take a look at something else. I've got the space station here pulled up as a picture, and here we can see the Destiny Lab. This Destiny Lab is actually the size of the International Space Station. This is our science lab. This is where we do most of our best work on the space station. It is the US lab. It's about the same size as a school bus. Now, here we can see the whole space station as it was assembled, so a piece at a time. And as we look down here, here's the US lab. The US lab is that section that actually where we do our science, and it is not in the center of the space station. Actually, it's just to the forward of center. The center of the space station is node 1. Node 1 is kind of a Tinker Toy connector piece, and that Tinker Toy connector piece definitely does give us connection out to either side, the airlock, and then to the US lab, and then it connects us to the Russian segment of the space station, which would be directly aft or behind, and that is the Zarya section, and then you go back to Zvezda. Zarya was the very first piece launched to the International Space Station from Russia, And then the next piece that was launched was Node 1 by the United States in the space shuttle. They were attached. Then Zvezda went up. I may have those two in the wrong order. I believe Zarya went up, then Zvezda, then we sent up Node 1. So we had those three pieces of the space station. And then it was a little while before we added the first truss segments. Once the truss segments were put up, we started having power for solar panels and the radiators that are here on the side. And when we get the whole space station completed, it is about the same size as 2 football fields next to each other. Now, if I get rid of that picture and we go to this picture, you can actually see the inside of the US lab. The inside of the US lab, as you can see, looks very, very messy. And that mess is actually due to the fact that all of these cables have to be run someplace. And unlike your house or your business, they can't run all of the cables behind the walls because they're not accessible. So they actually run a lot of these cables from segment to segment inside where they can actually access them and do work on them. So if we were to look inside our digital model of the space station, I can pull that up real quick. Here is what digitally the inside of the Destiny Lab looks like with no cables and nobody living there. So imagine you are buying a house and you go look at it and it is empty or it's a show home. This is what you see. You see the show home view. Well, we all know that once you start living someplace, it doesn't quite look like that, and we end up with a space station that looks something like this. And so here is the actual used model. I'm going to flip over to that view. Yep, we're looking at that right there. So here we can see the space station view with the lights up towards the top, and down at the bottom is where the air vents are at. That is to give the astronauts a sense of up and down. And then back here behind them, you can see one of the hatches. This goes back towards Node 1, which then would take you onto the Russian segment of the space station. And you can see they've got some really cool decorations. Obviously, there's somebody from the Air Force on board when this picture was taken. They've got the Air Force penned up. You can see right here behind his head, there's a label that says OVHD. That's for overhead. And then you also have, it says hatch. Down here, it would say floor. Over here, it would say port. And over here, it would say starboard, because the space station is actually flying towards us in this picture. And that's how the space station moves around the Earth, is it has a forward, it has a right, it has a left, it has an up, and it has a down to enable the astronauts to have all of those things in their head. It helps them maneuver through the space station a lot easier, and it also helps them to, in case of an emergency, not have a problem with getting confused or possibly having a problem with getting lost on the space station. And that was a lesson that we actually learned from the Mir space station, which preceded the International Space Station. Mir space station, if you remember your space history, they had a small fire on board. And each of the different pieces of the Mir space station, when they put them together, they didn't really configure them with all the same ups and all the same downs. So some of the pieces were actually different. You would go from this one, up would be up, and you go into the next piece right next to it, and up would be to the right. And so it was very disconcerting for folks that were in it learning how to maneuver through it. And so there were problems occasionally with astronauts getting misdirected through the space station. So we learned with International Space Station to keep all the ups up and all the downs down, and that does help them with navigating inside the space station. So as we look at the space station this way, I'm going to take us over and we're going to take a look at this picture right here. Here we can see some of the information, and all these pictures have come from NASA websites. So your tax money hard at work with all these great publications that are out there. And we'll talk more about the space station in coming weeks here on our Twitch channel here at Exploration Place. But today is just kind of an overview. Now, the International Space Station is a truly international affair. There were originally 16 different countries as a part of it. You had the United States, Russia, Canada, Japan, and then Brazil was a part of the initial discussions, but then they dropped out. So now there's 15 countries-ish, depending on who's in and who's out of the European Space Agency. The rest of the countries all come from the European Space Agency. The European Space Agency is made up of France, the United Kingdom, Belgium, Netherlands, Denmark, Norway, Spain, Germany, Italy, Sweden, and Switzerland. That is a specific order, but not in any specific order for who's more important. All right. So we have all of these countries building the International Space Station. The European module is called the Columbus Orbiting Facility. That is to the front of the space station, and then to the right as it travels forward. And then you have the Japanese module called Kibo. And Kibo means hope in Japanese. And the module has some segments that are allowed for the Americans to work in, and some that only the Japanese can work in. Same with the Columbus Orbiting Facility. There are parts of the Columbus Orbiting Facility that the Americans are allowed in, and some that they are not. So it just kind of depends on the different pieces or parts of the space station and what their agreements were at the very beginning. So as we're looking at these couple pieces, I am going to pull up our website, and here we have got, that's not the right one, there we go. All right, so here we've got the website. We're looking at the International Space Station's website from NASA, so nasa.gov, and I'm going to pull this right down here so we can see it nicely. Okay, cool. So this is where I got the graphic that we were just looking at, and then it's got some of the facts and figures. But one of the coolest part about the space station is that it's something that's up in space, traveling at that incredibly fast speed of 17,500 miles per hour, 5 miles a second, to wrap your head around that, and you can see it with your bare eyes. And so I've taken us here to this website, which is called spotthestation.nasa.gov. And Spot the Station actually allows you to put in your location here on Earth. And with that location, you can then look at what types of passes are going to have the space station coming overhead. So I'm going to tell you a little bit about how to do that. The reason this came to my mind is just this: within this last week, there's been several passings of the space station directly overhead of Wichita, Kansas. And I've been able to look up from my backyard and see the space station going overhead with the naked eye. No binoculars, nothing needed. You can even take pictures of it with your cell phone and see this bright spot moving across the sky. Now, how do you tell that it's the space station and not an airplane? First, the space station has no blinky lights on it. There's not going to be a red or green blinking light on it. There is only going to be, all you're going to see is a solid white light, and that solid white light is going to be traveling at a consistent speed in a straight line. It's not going to move, turn, anything like that. And as it moves across the nighttime sky, for the space station, it's going to be moving in an arc. Excuse me. And that arc for the last week here in Wichita has been from the southwest to the northeast. Last night's pass went from the southwest to the southeast. And so it's always traveling in the same direction. You have to think about how orbital dynamics work, and all of our rockets that we send into space get launched from, well, back in the day when it was space station, they were launching from Florida, and they would launch to the east. They would actually launch to the northeast and go right up the coast of the United States to match up the orbit height or the orbit trajectory with the launch platform that is in Russia, and that's in Kazakhstan. With orbits, you can never get to a higher orbital inclination than where you're, or a lower orbital inclination than where you're launching from. So the launch place in Kazakhstan is at so many degrees north above the equator, and so you can't launch to a lower inclination than that. So the space shuttle would actually have to launch at an angle that would take it up to the same angle that would hit that orbit from Kazakhstan. We might talk more about orbits and some of the orbital inclination information at a later date when we start talking about the Demo 2, which is we're going to talk about that a little next week. That's going to be the first time we launch American astronauts back into space from American soil, but we're going to twist. We're going to be using a private spacecraft that is being contracted by the government. So instead of paying the Russian government to launch our astronauts to space, we're going to be able to pay a U.S. company to launch our astronauts into space in collaboration with NASA. It's a really cool opportunity. We'll be looking at some of that for next week on Tuesday at 2 here on Twitch. So that's going to be happening next week. But we're not at next week yet. We are still talking about what's going on right now. I'm going to move a couple of screens around real quick. And all right, so got that started up right there. And as we look at how we watch the space station go overhead, the space station, as I said, is a solid light going across. You can use any number of apps. You can use software. I used to use heavensabove.com, heavens-above.com, to tell me what satellites or when the space station was coming overhead. But really, there's so many different apps and different places that I can suggest that you just Google and find what is most comfortable for you to use. But here we look at how do I spot the space station. And so we see some numbers that come up when you start looking at it. And the first thing you're usually going to have is a time, and it's going to have the date and the time. The date and the time are going to be very important because that's going to tell you when to start looking at the space station. And as you start looking at the space station, that date and time, you look for when it's going to be usually within 90 minutes after sunset or 90 minutes before sunrise, and is when it's going to be the most visible. That 90 minutes number is because you think about the space station being up in space above the Earth, and the sun, even though it's down for us here on the ground, the sun is still coming across and hitting the space station, and it's reflecting light down to us here on Earth. And that's what we're seeing, is that reflection of the sunlight from down here on Earth. So it's important to get that time right. The next line that you're going to see is you're going to see visibility. It's going to be visible for 4 minutes. So it's going to come into your field of view, and then it's going to disappear, and it's going to take it 4 minutes. Its max height is 66 degrees. How do I figure out 66 degrees? Do I need to get a compass or some type of navigation device? No, you don't need any of that. You just need your arm, your hand made into a fist, and that will help you with everything you need to figure out how high off the horizon it's going to be. So you take your arm and you go out at arm's length like this. You take the bottom of your fist and put it on the horizon. The top of your fist is about 10 degrees. So this is 10 degrees. So this says the max height is going to be 66 degrees. That 66 degrees then is going to be, we go one fist, two fists, that's 20, 30, 40, 50, 60, and then about halfway through the seventh fist is going to be 66 degrees. So that's when it gets to its max and its pass. You're going to be at 66 degrees. And then it tells you where it's going to appear, starting in the west southwest, and it disappears to the northeast. So all those different things do help us figure out how to watch for the space station. And then looking at it in 3 dimensions here on this 2-dimensional screen, you can kind of get an idea of how that works. Here it comes into view, and then it goes around. Here's the space station at its max height. It's 66 degrees off. 90 would be straight up. And then it continues over, and it disappears at 31 degrees above the atmosphere, or above the horizon in the northeast. All right, so you're going to be looking for that light going that direction. Now, is the space station the only thing you can see at night? Heavens, no. Depending on where you live, if you live out in the country where there's not a lot of light pollution, not a lot of car dealerships and parking lots and all those things that reflect light up into our atmosphere, or if you live out in the middle of a lake or in the middle of the mountains, you can see satellites for a long time. You can watch stuff go overhead all night long. For the first hour and a half, 2 hours, almost up to 2.5 hours after dark, because if a satellite happens to be orbiting much higher than the International Space Station, you can still see it longer because it's going to be reflecting that light much later. As you get into the beast of summer, when the sun's going down really, really late, you can see a lot of satellites. The space station, you can see the Hubble Space Telescope. You can see all these different satellites that are up there. There's a ton of them to look at. So it's really, really fun to figure out. Here we can see this is a time-lapse photo that somebody took of the International Space Station going overhead. And as you see that, it's basically a white line. This is because it's a time-lapse. They left the shutter open and it drew that white line going across. For anybody who used to be around down south when we were landing the space shuttle, before the Columbia accident, The space shuttle would travel right over the southern part of the United States quite often when it was coming in for a landing. And in the middle of the day, you could actually watch it draw a white line like that from the plasma that was being created by it. So, kind of an interesting thing that happened then. So, I'm going to, real quick, uh, pull up. There's a frequently asked questions, and that is, why do we have a space station up in space at all right now? I used to do a presentation about the International Space Station. One of my favorite questions was, why are we wasting money on a space station when we have so many problems here on Earth? And one of my favorite answers that I've ever heard is that working in space, NASA and the research that it does is not about space. It's about life here on Earth, and it's about making our lives better. In microgravity, we can do science that cannot be done here on Earth, because here on Earth, there is no way to turn off gravity. Despite what you'll see on TV, you cannot turn off gravity. Gravity always exists. So, in order to do very fragile type work, specifically, there's work being done with protein chains. And these protein chains here on Earth grow in 2 dimensions because gravity pulls them down. Even if you put them into a suspension liquid, that suspension liquid is in perfect system. And so you have to keep them moving all the time to keep them in a free fall state, uh, and they still break down. But you get into space on the International Space Station, because you're in this constant free fall around the outside of the Earth. There's no effective gravity, or no real effective gravity. It's called microgravity because there's like 0.001 of the pull on space station that you have here on Earth, but it's not noticed, especially not by these protein chains. So the science that we can do on the space station is hugely important to what we do back here on Earth, because there are ways that we can learn about different chemistry, we can learn about different materials in space in this microgravity environment, that we then bring that knowledge back here to Earth and figure out ways to improve our life here on Earth. For instance, there is some cancer research that's happening on board the space station that cannot be done here on Earth because of gravity. There has been some information about firefighting that was done in space to learn how to put out fires in this in microgravity situation, but they also figured out that they could use it in small craft like boats, or in the Navy, or you can use it in small houses. And all of these are different systems. One of those systems they actually did research on for firefighting was using mist, the water mist, to put out a fire rather than just buckets and buckets of water. You can think of different aspects where this might be useful for computer farms, museums. I've been in the museum world for a long time, and one of the biggest threats that you have is there's a fire somewhere in the building that sets off the sprinkler system. And if the sprinkler system gets set off, you can ruin artifacts or paintings. All kinds of things can get ruined. So the idea of using a mist system to disperse water that is maybe not going to flood out a museum is very, very good. Hospitals is another location where those mist systems could be very, very useful. So learning about how to do things in space usually will turn into that research will be a benefit that's back here on Earth. And that's just a really long way of saying kind of what they were talking about here in this frequently asked questions. But learning more about how to find the space station and how to locate it, I'm going to move us back a page. There we go. And here we can actually see a live ISS tracking map of where the space station is currently at. It might take it just a moment to load, so I'm going to let it load while we talk. Oh, there we go. Okay, so as we look at a map like this is like taking a globe, and if the globe was all printed on one piece of paper, you would slit it down from the North to the South Pole in a straight line, and then take that piece of paper off and put it flat out on a table. And that flat piece of paper, I don't know what they're asking me down here, so that's neat. Perfect, cool. All right, so this is the big flat piece of map from the globe, and so it's got this weird curves to it, but the space station is actually going in a straight line. But that straight line, when you lay it out flat on a three-dimensional sphere, looks like a big curved line. So this big curved line is the current location of the space station, and then the yellow line that we're following is going to be where it is headed next. So this is where it's been. It comes up, it goes down, it comes across, and then it follows this white line. The white line is where it's going, and this is where it's going to go next. This is about an hour and a half in the future because it just passed over basically that spot. You have this small degree of inclination that gets changed on every orbit. So if you are lucky enough to be someplace where the space station is going to go over twice in one evening, you'll notice that one time it'll be lower in the sky, the next time it might be higher in the sky, or it might be high in the sky the first time and lower the second time. It just depends on which of these two orbits you would be noticing. You'll notice also we have the day-night line. So right now over in most of Europe and Asia and Africa, it is nighttime. Right over here, Australia, nighttime. And the sun's just getting ready to come up here in Australia. Japan's just getting ready to see their sunrise come up. And the space station is coming, just about to come out of darkness into light. And then it is going to be traveling over South America here during the day here in Kansas time. So we can see right now it's at an altitude of 427 kilometers. There's the latitude and longitude. It's traveling at 27,558 kilometers per hour. So you can do the math on that and figure out that it's somewhere around 18,000-ish miles per hour. Actually, I can just switch it to the imperial system, and it's going to tell me that it is traveling at 17,123 miles per hour. So slightly less than 5 miles per second at an altitude of about 265 miles above Earth. Now we do have to punch that up every once in a while, and we have to punch that up to enable us to keep in orbit, because there are small particles that interact with the space station, slow it down, and it comes back down. So we keep boosting that orbit back up, and so it fluctuates anywhere from 200 to 275 miles above the Earth's surface. Back when the space shuttle was flying, we had to keep it low enough the space shuttle could get to the space station. But now that we're not flying the space shuttle anymore, we can be at a little bit higher atmosphere, a little bit higher altitude, which gives us less interference and less chances of running into some of the lower flying debris that is out in space. All right, so today we've talked a little bit about the space station, some about its history. We also talked about how to go out in your backyard and find the space station when it's going overhead. So I said that we were going to look at passes that were going to happen here in our neck of the woods. So I'm going to look up my old favorite, Heavens Above. Ooh, I have to learn how to type. There we go. .com. So I pull up Heavens Above. That's not it. All right. I should have had this pulled up before I started, but I did not because I kind of forgot. All right. So heavensabove.com, and it looks something like this. So here's our website. We're going to pull down, and we're going to pull up ISS for space station. It's going to give us 10 days of predictions. So 10 days for the International Space Station, and looks like we have a pass on tonight. Oh, we had a pass this morning at 5:16. It started 10 degrees above the atmosphere, or above the horizon, so right at the top of my fist if I had it out there, and then it worked its way about 4 minutes later. It was at a maximum altitude of 38 degrees, and it was in the southwest, and then it moved to the south-southeast, and it went out of view 3 minutes later. So that was a total pass of about 7 minutes, actually a little less, about 6 minutes of a pass that we have there. And that was a negative 3.3 brightness. Now, brightness magnitude, when you see this number, the lower the number, the brighter it is. It's a little weird, but that's just how it works. So you definitely want to be checking that out. Here I can see all of the different passes, not just the visible ones. So I can tell when it's going overhead. So this afternoon here in Wichita, Kansas, it's going to be going over at 4:52 to 4:56, and it's going to go out of view at 5 o'clock essentially. But I'm not going to be able to see that because it's during daylight and it does not reflect enough sunlight to be seen through the atmosphere, if that makes sense to you. Then coming up on the 20th, so tomorrow we'll have a pass tomorrow morning at 4:30 in the morning. It's going to last, it looks like, just about 4.5-ish minutes, 5 minutes, almost 6 minutes. Very cool. I can do math. and it's going to be a very high pass. It's going to be going at 82 degrees, so almost straight up as it gets to its highest point, and it is does not show its brightness, but if I turn this off, it will. It's going to be also a negative 3.8. So that is a very, very bright pass going overhead tomorrow morning at 4:30. If you happen to be in the Wichita area and you want to watch the International Space Station go overhead, check it out tomorrow morning. Now, next week here on Twitch, here at Exploration Place, we will be talking about Demo 2. That is the first U.S. launched based crewed mission for NASA and SpaceX. We'll talk more about it and what it means for the future of space exploration here in the United States. Until then, check out our other social media. We've got lots of stuff out on our YouTube channel. We have things out on Facebook. We have Facebook Live. Wednesday afternoons, we always have a challenge that's going on. It's going to be pretty interesting this week. I want you to check that out. That's at 3 o'clock on Facebook Live. It'll be posted to YouTube after that when we are done. But basically, all of these great activities are brought to you from here at Exploration Place. While we're closed to the public, we are not closed for business, and we are trying to keep you entertained and educated from Exploration Place. We even have a camp in a box, which is very, very cool. If you're more interested in that, check out our website at exploration.org, and it gives you something for your kids to do. There are camps throughout the entire summer with interactives, and you get a box with all the activities in it. It's very, very cool. Check that out on our web page, exploration.org. We will see you again next week, and in the meantime, stay safe, and we will see you next time. Thank you very much.